So what are the various components of atomic absorption spectrometry? You have an atomizer, radiation source, monochromator, and detector. I hope no doubts till now. If there are, please put that in the chat box so that we can address them. So atomizer, what is an atomizer? An atomizer is basically going to split your sample, which is going to be a solution, into very, very fine particles. So fine that they will be nearly having a size which is much smaller that can be visible by the eyes. And when this splits into these small particles, it is very easy to excite it in the flame. So it is called an atomizer. That means it is going to convert your sample into a very fine mist of particles. Radiation source, which is normally a hollow cathode lamp. Monochromator, for specifically separating out your wavelengths, because this time you have a flame and the flame will have, or the flame itself is going to have a very strong bandwidth. And to avoid all these radiations, you need a good monochromator which will be able to separate both your absorption spectrum and the flame spectrum. So you have to have a very good monochromator system. And lastly, the detector. So this is the block diagram of atomic absorption spectrometry. From the exam point of view, this diagram is sufficient for your exams. If you are asked to explain atomic absorption spectrometer, you can draw this diagram and explain it in detail. So in the diagram, we can see that we have the source, that is the hollow cathode lamp. Then you have a chopper so that it will pass the light to the flame alternately. Then you have the flame. Now if you see below the flame here, what you have is air. What you have is air. Now, and something called as a nebulizer. Now this nebulizer is nothing but the atomizer. Now the atomizer is going to basically spray your or split your sample into a very, very fine mist. So you have a suction through which the sample is entering into the nebulizer. When it enters the nebulizer, there is also air which is entering the nebulizer. You must have tried doing this sometime, that if you have a tap which is open and there is water flowing through it continuously and you try to close it, you will be able to spray it at a very high velocity. When it is spraying at a very high velocity, it basically is going to split into finer particles. And this way, nebulization can take place and the sample aerosol then moves into the flame. From here, the radiations are then given to the monochromator. Now in the monochromator, what will happen? In the monochromator, basically, the lights or the radiations from the flame will be separated. And only the radiations which have been absorbed by the sample are provided to the detector, and then you could have a display system which could either be digital or which could be analog. Nowadays, of course, you don't have analog systems, you normally have all digital display systems. The description is given here. You could just go through it for a second. Mayur, we will be seeing nebulizer in detail further. So I'll explain the concept again when we are doing nebulizers in detail. Okay, so let's move ahead. This is again a block diagram which you could go through. Now let's see the various components. So the first component, hollow cathode lamp, it provides the analytical light line for the element of interest. That means if I want to check if the sample is containing sodium, I will have to select the hollow cathode lamp which will have sodium as a coated material inside the cathode. Secondly, the filter also needs to be selected accordingly so that it will be filtering out exactly the ranges for sodium. As I had just given you the ranges, so 589 is the range, or 589 nanometer is the wavelength which is emitted by sodium when excited. So you have to select the lamp accordingly and the filter accordingly for atomic absorption spectrometry. It is a very, very sophisticated instrument in that terms. Then you have the nebulizer. Now, what is the nebulizer doing? It is sucking up liquid sample at a controlled rate. Then it is creating a fine aerosol for introduction into the flame. It mixes the aerosol and the fuel and the oxidant thoroughly for introduction into the flame. We will be seeing exactly what a nebulizer is made up of just in some time. Then the flame, it basically will destroy the analyte ions and break down the complexes. It creates atoms, the elemental form of that element, which is of interest. It could be either iron, it could be copper, it could be zinc, it could be sodium, it could be potassium, calcium. Then the monochromator, it isolates analytical lines, photons passing through the flame, removes scattered light of other wavelengths such as from the flame, and in doing this also a narrow spectral line will come out to the photomultiplier tube for detection. Detector is normally the photomultiplier tube because the line is a very fine line and of a lower intensity, so it needs to be amplified. As a detector, the PMT determines the intensity of the photons, the analytical line of these monochromators. So, atomization, what is the process? The process by which the sample is converted into an atomic vapor is called atomization. So, what are the types of atomizations? It could be flame atomization, it could be electrothermal, which is nothing but your graphite furnace, or it could be other specialized techniques such as glow discharge or hydride or cold vapor atomization. Depending on the type of sample, we will have to implement the type of atomization. So here you can see the various types of atomizers and typical temperatures at which these atomizers operate. They operate at a very high temperature